27. We have this diagram here. We're given in the diagram, h represents the terminal point's distance to the right of the circle's center uh, in radius length. So that's going to be the cosine of the angle. It's going to be the x coordinate, right? Cosine, the result. And so let's see what the question. What are the measures of the two angles shown in the diagram, which both have terminal rays located h radius lengths to the right of the center of the circle? Express your answers in radians rounded to 3 decimal places. Okay, so the red angle here, so this one, which ends up here. Okay. What we have is that the x coordinate is 0.75, and that's radius length. So for that, for this problem, we're able to assume or just treat it as if the radius was 1, as if it's a unit circle. So we just need to take the inverse cosine, and that will give us this angle. So inverse cosine of 0.75 will be the red angle. And just kind of eyeballing it, you know, it's close to a 45 degree. Of course, they don't always draw these things to scale, so, but it's about what I would assume, some, you know, in the 40s, right? Somewhere between 40 and 50. But we're not in degrees, so then I'd have to convert that over to radians. And that, I guess, seems reasonable. Pi over, so 45 degrees is pi over 4. Let me just do a check. 45 degrees is pi, pi divided by 4. Let's see, what is that in radians? 7/8. So it's a little bit less than pi over 4, so 42 degrees. Makes sense. So our answer, sorry, we'll do that. Our answer is 0.7227. 3 decimal places, 7.723. So that's the red angle. To get the blue angle, we have to come around to here. Now notice this is going to be in the 4th quadrant. It still has an x value of 0.75. We'll give you that much, right? But when you take, if you took the inverse cosine of this, right, we see what we get. So what we have to do is what would we do? Well, the angle we got here, this 0.723, is the red angle. It's this measure here. So what we know is this measure here, we could think of it as negative, if we went backwards, would be negative 0.723, right? And so if you take 2 pi minus negative 7.23, you would get the blue angle here. So right, this would complete a whole circle, this plus this. So for the blue angle, again, we've already we've taken our inverse cosine part. It won't give it to us directly, but what we do is we'll take, for the blue angle, just take 2 pi minus 0.723. Okay, so 2 pi minus 0.723, 5.56 to 2 decimal places. So the blue angle is 5.56 radians. Rads. Okay. Which of these angles shown in the above diagram are the values of arc cosine of this? So the red, I'm just going to put it here. That's the red one, kind of for the reason we talked about, because the when we use the domain of cosine, we're going from 0 to pi, right? And so that when we take an inverse cosine, it's going to give us a range and output of from 0 to pi. So we can't get the blue angle except for with the calculation. Okay, so it's kind of, we take, when we're using inverse cosine, the angle has to be, for the answer to be the direct answer, the angle has to be between 0 and pi. So if the radius of this circle is 10 centimeters, how far apart are the 2 points located where each of these rays intersects the circle? In other words, what is the difference between the y-coordinates of the 2 points? Okay, thanks. Um, so we're looking for the y-coordinates now of these 2 points. Since we do have the the angle measures, right? The red angle's 0.723, the blue angle's 5.56. What we can do is find the y-coordinate simply by taking, in this case, 10 centimeters times the sine. So our sine theta. So the red one is going to be 10 sine of 0.723. And the blue one is going to be 10 times the sine of 5.56. So let's go ahead and plug those in. 10 sine 0.723. That's going to give us a y-coordinate of 6.61. I guess we're rounding to 2 decimal places, 6.61, 6.62. And this, actually, the x-coordinate, because this is in terms of radii, would be 7.5, the actual x-coordinate. But we don't need that right now. This one is going to be, my guess is it's going to be negative 6.62. But let's see if my guess is correct. Yep, a little bit different, but to 2 decimal places, negative 6.62. And so what we do is we subtract these two. The difference between them will give us our distance. And so it's positive 6.62 minus negative 6.62. We're going to get 12 point something, 13, right? So we take this one, 6.62 minus a negative 6.62, 13.24, 13.24. And we got a little bit of rounding error in, that was for 3 decimal places. Why did I only go to 2 decimal places? Well, I guess I should have gone to 3 decimal places, but we get close enough. We round to 2 decimal places. I get the answer's 2.23. So that's, again, the other part of it. When you check the answer, it's a little bit off, but I should have said to round these to 3 decimal places. So what I really should, 5.560. That's okay. But in their answers, they're not rounding it to 3 decimal places. They're using, they end up using like 5 decimal places. So that's okay. Anyway, I'm satisfied with our answer here. be close enough to be able to choose the right one when we get to the exam.